Hi, good morning. Let's talk about what is ANN, Artificial Neural Network. ANN is one of the most commonly used model in machine learning. The reason why it's called a neural network is because it tried to follow the idea of biological neural networks in animals, right? Just like what is shown in this figure, we have all these neurons, axon, dendrites, and more importantly, right, the connection between the two neurons by means of these synapses. Basically, the key features of biological neural network is the synapses, which is the connection between neurons. They are not directly connected, but with a gap. And so the dendrites transmit input signals to the neuron, and then an axon transmit the output signal over the synapses towards the dendrites of the other neurons. It depends on the strength of a connection between two nodes of the signal, right? So as to make sure that the signal can pass through the synapses. So that's basically the concept of neural network. Then ANN, right, try to borrow these ideas from biological neural network and then applied it in machine learning. Let me direct code this paragraph to explain what is ANN from Wasak and Shapak 2003. So ANN models simulate the electrical activity of the brain and nervous system. Processing elements they call neurons are connected to other processing elements. Typically, the neurons are arranged in a layer with the output of one layer serving as the input to the next layer and possibly other layers. A neuron may be connected to all or a subset of the neurons in the subsequent layer, with these connections simulating the synaptic connections of the brain. So something look like this diagram, right? We have the left-hand side, the input layer, and then in the middle, there's some processing and then activation function and to pass through to the output layer. So basically it's based on the weighting of the input parameters. So here, let me continue the code. Weighted data signals entering a neuron simulate the electrical excitation of the nerve cell and consequently the transference of information within the network. Then the input values to a processing element are multiplied by a connection weight, W, that simulate the strengthening of the neural pathway in the brain. And it's through the adjustment of the connection strength or weight that learning is emanated in ANNs. Okay, so in order to explain what it means, I here try to make use of a simple example, right? It is divided into input layer, hidden layer, and output layer as shown. First, right, we assume that there are only 3 input parameters, just like this one, right, from the left-hand side. If the decisional predictions of this learning process depends on 3 parameters, then we get into this input into the input layer. Then we impose a weight to each of the parameter. In this example is 0.7, 0.6, and 1.4. So with the weighted average, we sum them up and then test by adding a bias and making use of an activation function to test whether it compiles with the requirement or not, to determine whether it can pass through the output layer or not. And then there's a feedback loop and to inform the input layer whether the weight have to be adjusted so as to improve the accuracy of the outcome. So there must be the model answer in the output layer so as to compare. So this is the kind of learning from mistakes process, which is exactly the learning process of human beings. So we apply this learning by mistakes, by making mistakes, right, in machine learning, which I have proposed in a paper in year 2006. So machine learning decisions are bound to make mistakes, and data analysis also would have errors. In order to improve the prediction, so every time the predictions are made by an ANN, we'll pass through an activation functions to design whether go or no go. So there are several commonly used functions to as the activation functions. Here I show two commonly used function. One is the SIMO functions, and the other is the TANH function. Yeah, so they look like this S curve. So they are also called S functions. One of the key points of machine learning, that is the training and testing process. So in the training process, well, we have to provide the model answer to compare with the prediction of the machine, right? So as to tell the machine how accurate the predictions are, and then try to feedback these comparisons result to help the machines to adjust the weight so as to improve the prediction until a predetermined level of accuracy. So it works very similar to training children to learn, right? Which also required an open atmosphere with honest and reliable coach to encourage children to make mistake in a safe place. Let's say now we are going to train a machine to carry out probability price appraisal, and let's say we only provide 3 parameters, namely the number of rooms, the year of completion, and the floor area, and all other variable will be constant. So here I provide some training data. Say, for example, the first one, right, in a 1-bedroom, 23 square meters floor area, the house was built in 1990. Then, right, ask the machine to guess what would be the market price. And we provide the actual transaction price for the machines to learn. And after a numerous number of training sections, then the machine will come up with some kind of weightings for each of the parameters. So just like what we have done in this diagram, so the 3 parameters will be connected to from the input layer to the hidden layer with the weight, and then the hidden layer connected to the output layer, which is a single prediction outcome. That's the consideration for house price. Then after the training, then we can provide testing sections. Say, for example, we ask how much would it cost, or would it priced for a 2-bedroom, 50 square meters, and for a house built in year 2000. So to test whether the system is accurate enough. For detailed calculations, step by steps, here is a YouTube, right, which shows the calculations of ANN using Excel. Also, there are some other YouTube which would provide interesting examples to explain ANN. And here is a link provided by 3Bu1 Brown. They try to explain how to use ANN to judge handwritten numbers from 0 to 9. That's all for today. Thank you.